The first one, for instance, is 2x minus 8y is equal to 6. And the second one is x minus 4y equals 8. Now, first of all, x and y are our variables, so we have two variables, we have two equations, so we should be able to solve this system of equations. Now, the easiest thing to do, just looking at it, is over here we have the x. It's just nice and off by himself, so let's move the 4y over here by adding 4y to both sides. So we add it to the left, we're just going to have x left over, and on the right we're going to have 4y plus 8. All we did was add 4y to both sides. Then we will take this value of x and we'll stick it into the equation in the position of x and continue solving the same exact thing that we've always done. So we'll have 2 times x, but now we know that x is 4y plus 8. Minus 8y is equal to 6, and now we solve for y, same as we always have done. So the 2 times the 4y gives me 8y, and the 2 times the 8 gives me 16, minus 8y is equal to 6. So immediately I start to combine terms, and I see I have an 8y and I have a negative 8y. And I don't have any y's here or any y's here. So really what's happening is the y's cancel out because 8 minus 8 is 0. So really what I have left is 16 is equal to 6. Now let me ask you a question. Is there any possible condition when 16 is ever going to be equal to 6? No, there is no situation ever that 16 will ever equal 6. This is an example of what I was telling you. If you come up against something weird, and this is just an example of something weird, you get a nonsense sort of result that doesn't make any sense at all. What this is telling you, what the math is telling you, is that there is no solution to the system of equations. So when you get something weird like this that's impossible, like this is impossible to actually happen, what this is telling you is you have no solution to this system of equations. So what this means is these lines, because these are two lines, must not cross. Think about what a system of equations is, right? This is a line and this is a line, and wherever they cross, we've done this before when we're doing it by graphing, that's what we call the solution. Well, these lines must not cross at all, and this is the kind of thing you get whenever the lines don't cross. Basically, these are parallel lines. If you have a line like this, and you have a line parallel to it, it goes on and on forever, and those lines never ever cross, so they never have a solution. So if you get a nonsense answer that can never ever be true, it means that these guys don't cross. Now let's investigate that a little bit. Let's just take just a second since we get such a weird thing. Let's take the first equation, 2x minus 8y is equal to 6. Let's solve it for y and see what the line looks like. Let's put it in slope-intercept form. So we'll take the 2x and move it over by subtraction. We'll have negative 8y is equal to negative 2x plus 6. Just subtract 2x from both sides. And then we're going to divide both sides by negative 8. So here we have negative 8. And so on the left, we're just going to be left with y. And over here, we'll have negative 2x over negative 8. And then we'll have plus 6 over negative 8. All right? So what we're going to have, what you're going to have here for this equation is going to be, what is 2/8? Well, first of all, the negative divided by the negative gives you positive. 2/8 reduces to 1/4, so it's 1/4 x. And then you have the minus sign here. What is 6 over 8? You can divide both of those by 2, and you're going to get 3/4. So this is kind of like equation number 1 in slope-intercept form. Right? This comes directly from the first equation. If I needed to graph it, this is the y-intercept, this is the slope of that line. Now let's take a look at the second one. The second one is x minus 4y is equal to 8. Let's again put that one in slope-intercept form. So what we'll do is we'll take the x and move it over by subtraction. So we'll have negative 4y is equal to negative x plus 8, just subtracting, right? And then we'll have y is equal to, we're going to divide both sides by negative 4. So this will be divided by negative 4, and this will be divided by negative 4. So we'll have negative x divided by negative 4 plus 8 divided by negative 4. So what this means is that y is equal to, what is this? Positive 1/4 x, and then you have what over here? Minus 2. Right, minus 2. All right, so this is the second equation. So what do you notice when you take a look at both of those? Well, clearly they're not the same line, right? This y-intercept is totally different than this one. However, the slope of this is 1/4 and the slope of this is 1/4. That means if I graph them, these lines have exactly the same slope. They will never, ever intersect. So you could easily tell if I gave you these two equations that they were parallel and there would be no solution, but we weren't given that. We were given the equations in a slightly different way to make it kind of hard to see that. The way that you see it is whenever you start substituting in things, you get a nonsense, something that's impossible to be true. So these do not have a solution. This is what you would circle right there, no solution. So that's case number one. That's generally what it looks like when you have something that doesn't have a solution. Now let's take a look at another case, which is equally interesting. What if I have y over 2 is equal to 2 minus x, that's equation 1, and then I have 6x plus 3y is equal to 12. That's equation number 2. So I want to solve this. There's many ways I can go, but I'm going to go ahead and multiply both sides of this equation by 2. And the reason I'm doing that is so I can cancel the 2's, and so what I'll have on the left is y is equal to, on the right, distribute the 2 in, distribute the 2 in, and what I'm going to get is 4 minus 2x. All I was doing was getting a nice equation in terms of y, and then I will take this equation for y, and I will stick it in the y spot and see what we get, just like we always do. 6x plus 3 times y, but now I know that y is 4 minus 2x, equals 12. So I have 6x, and then what do I have? 3 times 4 is 12, and then 3 times negative 2 is negative 6, so I have plus 12 minus 6x is equal to 12. And so what do I get here? Notice I have a 6x, and I have a negative 6x. So again, they're going to cancel, they're going to disappear because they subtract out, but what am I left with in this case? 12 is equal to 12. Now this is different than before. Before, we were given something whenever we got down to this point. It was definitely weird, but it was never ever true. 16 can never be equal to 6. Now we're given a situation where 12 is equal to 12. This is always true. It's a little different. It's not that it's never true. It's literally always true. 12 is always equal to 12. So this does not mean that there's no solution. This means the opposite. This means that these two equations are always in solution. That no matter what you do to x and y, these two lines always are solutions at all possible points. So it's telling you that there's no single point that's a solution. When you get something that's telling you something that's always true, it means that all possible points on this line are solutions. And at first you're like, what the heck could that possibly mean? What it means is that you have infinite solutions. Infinite points are solutions to this set of equations. Now, in order to see why that's the case, let's take a look and investigate. Let's take a look at this first equation, which we actually already did. We got y, I'm going to put it in slope-intercept form, negative 2x plus 4. Okay, that was this one. I just moved the 2x, the negative 2x here, and put the 4 at the end. Now let's put this one in slope-intercept form. What we're going to get here is 6, you know what, we'll do it this way. Well, let's just write it again. 6x plus 3y is equal to 12. So let's take the 6 and move it over there by subtraction. So we'll get 3y is equal to negative 6x plus 12. And then I'm going to divide by 3. So I'll divide this term by 3 and this term by 3. And so what I'm going to get is y equals, what is this guy? What is negative 6 divided by 3 is negative 2. So I get negative 2x. 12 divided by 3 is 4. Take a look at what you have. These two lines are exactly the same. Even though they look different, the original equations look totally different, that was just because they were manipulated to look different. In reality, this line that we were given and this line that we were given are the same line. That's totally clear when you solve them and put them in the same form. You can see the slope is the same and the y-intercept is also the same. So yeah, they're parallel just like before, but these actually lie on top of each other. So if I were to graph this, right, x, y, this has a slope. I'm not going to graph it really well, but I know the y-intercept is up here and I know the slope is negative, so I know that this line is going to look something kind of like this. And then I've got the other line, it's exactly the same thing, so I can just kind of trace over it. Both of these lines lie smack on top of each other, so that means that when we say that they're infinite solutions, it doesn't mean you can pick any point out of thin air and that it's solutions, but that any point anywhere is a solution. It means that this point consists of an infinity of, this line consists of an infinity of points in all directions. And no matter what point I pick on this line, of the infinity points that are available, it's always going to satisfy the system because both of these lines are the same. They lie on top of one another. So that's why you get an answer like this that seems to imply that it's always true, meaning there's an infinity of solutions because these lines are exactly the same. So to summarize, if you start solving a system of equations and you get a nonsense answer that can never be true, you write down that there's no solution because these lines don't cross. And if you ever get a weird situation where the variables kind of drop away like this and you get something that's always true, then you write down that there's an infinity of solutions. So you're not writing a single point, you write down that there's an infinite number of possible solutions to this system. So make sure you understand this, solve it yourself, make sure you can come up with the same conclusions. Follow me on to the next lesson. We're going to continue talking about systems of equations, but we're going to learn new and different ways to solve them.
Learn anything at mathandscience.com.